Hello everyone. In three dimension, we know how to compute the volume of sphere, cylinder, and cone. But how can we compute the volume of any three-dimensional geometric shape? We can compute the volumes of these type of shapes using integrals. But first, we should define a solid of revolution. So, what is a solid of revolution? When we rotate the curve about a given axis, we get a solid of revolution. Here, you see the blue area on xy coordinate system. Let's rotate the curve about the x-axis. By doing this, we obtain a three-dimensional solid. The objects at the right-hand side are perfect examples of a solid of revolution. So, how can we compute the volumes of these objects? Now imagine cutting the blue area into tiny rectangles perpendicular to the x-axis. When we revolve this tiny rectangle around the x-axis, we obtain a disk or a cylinder. It's easy to compute the volume of a disk. When we add up all of the volumes and increase the number of disks, the summation approaches to the volume of a solid of revolution. Mathematically, this means integral. The volume of a single disk is given by the area of the circle times the height. Here, the height of the disk is dx. Basically, what we do here is to sketch a typical cross-section, which is a circle because it's built by revolving a rectangle. So, the radius of the circle is the height of the rectangle. We will have more videos about computing the volumes by integrals, but in this video, we will only analyze rotations about the x-axis. So, let's begin with the examples. In the first example, we have the region bounded by the curve y equals square root of x and x-axis from x0 to 2. We want to compute the volume of this solid generated by revolving this region around the x-axis. So you see the region in xy coordinate system. As you see in our animated graph, when we revolve this region about the x-axis, we get this solid shape. Has it reminded something to you? If you pay attention to the airplanes when you travel, this object is like the blunt nose of the airplane, and it is very important for its dynamics. Now, to compute the volume, let's sketch a typical cross-section and find this area. The radius is the distance between the curve and x-axis, so we get the area as pi times x. To construct the whole volume, we integrate the cross-sectional area between the intervals, from 0 to 2. This is one of the main integrals, so we get 2 pi when we compute it. As you see, this was a pretty easy example, so let's have a look at a new question. So here we have the region bounded by the curve y equals 3 minus x squared and the lines x equals 1, x equals minus 1 and x-axis. Here we want to compute the volume of the solid and it is generated by the revolving this region about the x-axis. As you see in the animation, this is the geometric shape we obtain. By following similar steps, let's sketch the disk and compute the area of the cross-section, which is pi times 9 minus 6x squared plus x to the 4. By filling the whole volume with this disk, we get the whole volume. So we integrate a of x from minus 1 to 1 and we get 72 pi over 5. Okay guys, let's look at our last example. This example is going to be a bit different. In the previous two questions, we revolved the regions about the x-axis, and x-axis was one of the bounds. But here, we will do something different. Here, we have the region bounded by y equals e to the x, y equals 1, and x equals 1. We revolve this region about the line y equals 1. Here, as you see, the line y equals 1 is one of the bounds. So when we revolve the region, there is no hole inside the object. That's why we can use the disk method. We will construct a disk and find its radius, which is the distance between the curve y equals e to the x and the line y equals 1. We get e to the x minus 1. The area of a cross-section comes from pi times e to the x minus 1 square. We get the whole volume by integrating a of x from 0 to 1. So, what if we revolve this region about the x-axis? The solid would have a hole in it. We need to modify our formula for this new geometrical shape. We call this new method washer method, but we will see this in our next videos. So let's summarize what we have seen so far. We have the region and we revolve it about its bound. We compute the volume of this solid by disk method. Here's the steps you need to follow. First, construct a cylindrical disk and make sure its center is on the revolving axis. Second, we compute the area of the cross-section from the area of circle. Finally, we integrate the area between the intervals. That's all for today. If you have any questions, please comment below and do not forget to subscribe for future videos. Bye!